Now I'm going to solve a system of linear equations by substitution, but neither one of them is solved for x or y. So before I can circle and do some substituting, I need to solve one or the other for either x or y. I think I'll just take this top equation, negative x plus y equals 3, and make it y equals mx plus b. We're used to that anyway, so let's add x to both sides, which means I'm getting this x over to the other side of the equation, and I'll have y equals x plus 3. Okay, so one of them is solved for. I can take what y equals x plus 3 and plug it into the y's position in the other equation. So now this equation becomes 3x plus, instead of writing y, I write x plus 3, and then equals negative 1. Remember that I can't solve it if there's two variables, but if I can manipulate it where there's only one variable, I can solve it. So now I have a 3x that I need to combine with this invisible 1x. 3 plus 1 is 4x. And then, what was that? A plus 3? Yeah, plus 3 equals negative 1. To get this x alone, I will subtract 3 from both sides. And I have 4x equals, add them and keep the sign, negative 4. And then divide by 4. And I have x equals negative 1, which is half of my answer. Now I need the y. Well, the smartest place to put that negative 1 would be right here because it's already solved for y. I'm going to draw an arrow as to where it's going to go. Y equals negative 1 plus 3. And negative 1 plus 3, you would subtract them, and you'll get a 2, positive 2 on that. So here's the second part of my answer, and that means it's negative 1, 2. If I were to put these in y equals mx plus b form and graph them, this will be the point where they intersect. So this is the solution. And remember that you can plug these numbers back into these problems to make sure that it's correct and that there's not a sign error somewhere.